Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj and in this video we'll be having a look at the basics of differentiation. Now before I begin the video, please do note that I will only be looking at the basics and basics only. All the quotient rules, product rules, all the second derivatives or equation of tangents will be done in a later video. This video is solely for the purpose of basics of differentiation. So, without wasting much time, let's start. So before we go into examples, we need to have a look and we need to see what is differentiation. In layman terms, differentiation is the measure of the change to a function value with respect to a change in its arguments or input. So as we know, when we are differentiating, we write something like this: dy over dx, and you then write your whatever your answer is. But how exactly do we get to dy dx? Now suppose I have an equation. Let's say let y be x to the power of n. If y is x to the power of n, my dy dx is simply x to the power of n minus 1, with it being multiplied by n. Now this may look complicated at first, but if you look at it carefully, if your y is x to the power of n, your dy dx is simply your n times your x, and whatever that is, to the power of your original n, and you just subtract 1 from it. And that is how you derive your dy dx. Now let's have a look at a few examples. First example I have says find dy dx of x to the power of 5. So this is simply, you could say, your y. Your y is equal to the x to the power of 5. So now my dy dx, as we have from the rule over here, simply if y is x to the power of n, the dy dx is nx to the power of n minus 1. So my dy dx here would now be 5x to the power of 4. Now, why 5? Because my 5 simply went over here and times itself by x. And since there is no other coefficient in front of x, we know that simply means 1. And 5 times 1 is still 5. So that's why I have my 5 over here. 5x and to the power of 4, because the rule says that's to the power of n minus 1, and my original power was 5, so I just subtracted 1 from it, and that gave me the 4 over here. On to the next example. It says to differentiate x. So you could say y is your x. Now we know when you're saying x, this is simply to the power of 1. So your dy dx would now be 1, because your 1 now comes in front, x to the power of 1 minus 0, which is 0. Now this can be simplified. We know that when you write 1 over here, this simply means that there's nothing, there's no coefficient in front of x. So this is simply x to the power of 0. And from our law of indices, we know that anything to the power of 0 is 1. So your answer is 1. That means that gives us a ground foundation that whenever you differentiate x by itself, you will always have 1. On to the next example. It says find the derivative of 3x squared. Now if I have been using derivative, that's another way of saying the differential, or you need to differentiate, it's just another word. Now to find the derivative of y equals to 3x squared, we use the same rule. So dy dx is simply your 2 comes in front, so you now have 2 times 3x to the power of 2 minus 1, which is 1 to the power of 1. We know 2 times 3 is 6, so this becomes 6x to the power of 1, and since it is to the power of 1, we do not need to write that 1. And that is your final answer for that question. On to the next example. It tells me to differentiate 6. Now I could go into all the logic and algebra to prove this, But the simplest way to go about this is that whenever you differentiate a number or an integer or a number or an integer, any term that's independent of x, your derivative is nothing but 0. And this is just the ground foundation you need to know. If you are differentiating 6, maybe 29, maybe 99, maybe 0.2, any term independent of x, your derivative rather, is 0 at all times. Next example it tells me to find the derivative of root x. Now we know from our laws of indices, and please, if you are uncomfortable with the laws of indices, please do have a look at my previous video which covered laws of indices, all of them. We know that root x can be represented as x to the power of 1 over 2. So let's rewrite that. Let's say what we need to differentiate is x to the power of 1 over 2. Now again, using the ground foundation rule, we know that this 1 over 2 will now go in front and the power will be subtracted by 1. So this becomes 1 over 2x to the power of 1 over 2 minus 1, and that is minus 1 over 2. You could go ahead and simplify this even further, but for this video I'll just leave it as it is right here because I think this is enough to get you your marks. Next example it says find the derivative of 1 over x cubed. Now again, from our laws of indices, we know that this can be represented as x to the power of minus 3. So if the x to the power of 3 would become the numerator, and in order for that, the power would become minus. And finding your derivative of that, again, we use our rule. This minus 3 goes in front and subtracts the power by itself by 1. If it goes in front, this becomes minus 3x, and minus 3 minus 1 would give you minus 4. That is your final answer for that question. Again, minus 4 because the power got subtracted by 1, and minus 3 because there's nothing in front of x, meaning it's 1 over here. You bring your minus 3, 1 times minus 3 would give you minus 3. On to the next example. It says find the derivative of 2x cubed minus 5x squared plus 6x. Now this may look complicated at first, but all we have to do is simply differentiate each of these terms separately and then bring them back together at the end. We know to start with that this 6x, this is simply to the power of 1. So let's start with our derivative rather. dy dx is equal to now 2x cubed. All you do is take your 3 here, so you now have 3 times 2 x to the power of 3 minus 1, which is, as we know, is 2. And doing this, we know 3 times 2 is 6, so you have 6x squared. This is only for this part over here first. Now again, where did we get the 6 from? We took the power we had, which was 3, and we brought it in front of x. Now in this case, x already had a coefficient, which was 2, so we had to times it by 2, which gave it 6, and you got 2 over here because you took away 1 from the original power, which was 3. Now doing the minus 5x squared, again, same rule, take the 2 here, subtract 1 from the power. 2 comes down here, it has to times itself by minus 5 first, because there's already a coefficient. Minus 5 times 2 gives you minus 10x. And 2 minus 1 is 1, but we don't need to write it because this also means the same thing. And finally we have 6x, and we know this is to the power of 1, so you bring up 1 over here. 6 times 1 would give you 6, and take away 1 from that power, so 1 minus 1 will give you 0. So we would have 6x to the power of 0. We know anything to the power of 0 is simply 1, so we basically have 6 times 1 again, and this is also 6. So bringing them all together, we know that our dy dx is 6x squared minus 10x plus 6. And that is the final answer for that question. And this does bring us to another rule that suppose if y is equal to kx, saying k is any number, your dy dx will always be k. So this is another rule that should be remembered. And on to the final example for basics of differentiation. I have y, let's write that again, y equals 2x into 2x minus 1 into x plus 3, and this is a challenge question. So please do pause the video and have a go at this by yourself, and then resume the video to see if you are correct. If you are incorrect, please take note of your mistake. Now before I start, I know that I need to expand them out. Now if you are uncomfortable in expanding brackets, you can look at my video at expanding single, double and triple brackets. Now expanding this, I know that y is equal to 2x squared minus x into x plus 3. How I got this is that I just simply, if I expanded this, so x times 2x, that's 2x squared, and x times minus 1 is minus x. So now I need to multiply these two out, so I will now have y equals to 2x cubed, because 2x squared times x gives 2x cubed, 2x squared times 3 gives me plus 6x squared, minus x times x gives me minus x squared, and minus x times 3 gives me minus 3x. And collecting my like terms, I know this is y equals to 2x cubed plus 6x minus x squared plus 6x squared minus x squared, that is plus 5x squared, and then there is a minus 3x. So now that we have it as simplified as we can, so this is our equation now, we need to find dy dx. So doing them again, we can do them separately. We know this is 3 comes down here, and subtract 1 from the power, so 3 comes down, times itself by 2, so 3 times 2 gives you 6x, and 3 minus 1, that is to the power of 2. Now for this, so the second part, we know 2 comes down here again, so 2 times 5, that gives you 10x, and you take away 1 from the power, this becomes to the power of 1, but we don't need to write that because this also simply means the same thing. Again, in both of these we had to times the power first because there was already a coefficient in front of x. And the last part is simply minus 3. From that rule we established over here that if y is kx, dy dx is simply k. So simply if it's minus 3x, dy dx is just the number over here. And that is the answer to that question. So thank you for watching this video, guys. Hopefully you enjoyed it. Please do perform an LSS, that is like, share and subscribe, and also a shout out to YouTube channel Double Beam for giving me support. You guys should definitely check out that channel. So thank you for watching. Have a nice one.